Hello, everyone. This is my video I will begin to show you everybody the somewhat example forecasting. However, this is not a relevant, a exact good model, since this is just a representation as a somewhat guide to you everyone, which you could somewhat benefit from this. So in order for you to strengthen your model as well. So this will be, I'm having here a data set of Spotify daily charts, which from January of 17 up until the, what year is it? Let me check. Um, that was 2023. So from 2023 of October. So what I'll be going to do right now, I wanted to forecast the future streams. There is a streams here and a specific artist, which will be Bruno Mars. So we will be going to do that. What will be the streams up until the 2026, for example, of December, say for example, like that. So let's actually proceed in our code here. So in our code pertains to that, that is basically like this. So I've imported the data, then printed the data set into the data frame. So I've actually showed the data set here, a few data set in a data frame right now. After that one, I was able to do the data cleaning definitely as well as I go along here. So here then I define the list of artists that I wanted to filter. So I've decided to show five of those cases. So when I printed the first five set in my data frames, this will be the artist shown: Bruno Mars, Maroon Five, Bruno Mars, Moira, and Bruno Mars. However, that somewhat focus with those artist. However, later on, I will not begin to show everything. I will just focus with Bruno Mars. So afterwards, I've removed the rows with any missing values. So before, it is 49,000. I mean 495,622. The same thing because there is no missing value. Then I converted the date column into the date time format just to strengthen that one, so that it will be basically maintain the data set as well. Now, after that, I normalized the artist name, ensuring the consistency of the format with the capitalization. Like say, for example, Bruno Mars, like that. Because here, then, for example, if say Bruno Mars, if for example, naka small case here, so that's why that we need to do that as well for to normalize your um data set. So here now I've splitted the data with 80 and 20%. So the 20% testing set will be utilized for the evaluation of the evaluation metrics later on. So the training set, I've actually put it at that in the data frame as well. Here, the first five data set for training set, this will be, and for testing set, this will be here. So that's how we will begin to do that. I've actually shown the first five data sets in my data frame. Now afterwards, I've since I will begin to use the Holtz linear exponential smoothing, so I've actually implemented the um that here then already. So I do have here the smoothing level 0 0.6 and smoothing trend 0 0.3, which afterwards I've extracted the smooth level and trend, then plotting the historical data. We're using the formula actually. So we create the daily time series of streams as well for the Bruno Mars data only. So we actually used here the training set of Bruno Mars so that we could be able to configure this one. So I with the actual data set with the historical data sets that is in the in color blue actually. Then the smooth trend that is the yellow, and the smooth level that is somewhat as what if you will begin to calculate that in manual calculation, it must be related closely to the historical data. So that's why if you can see that right there, that your level of the data set as well as the your data set as well as your level is somewhat related to each other. So that is basically good. However, class, this is not good at all because later on in your forecast, since we are dealing with this holds linear, so it must be linear. So there's no like fluctuation nga magtaas nga mag downtrend man. So it's not like that. It's not like with Arima or Arimax or Sarima that you could somewhat get the fluctuations pertains to your data set. So I've actually shown the historical data and smooth data right there. Afterwards, this is my forecasted data, and I also showed here the data set. So that's how you will do that. After I've already implemented the data set into the training of the model. So right now, we will begin to get the testing set evaluation metrics. So after this one, since I need to also secure, sir, what is the 2026 time here? What is the data? So I've actually shown that here. So from the data frame, I've actually printed at least 10 first 10 forecasted streams in the future. So from 2023 October 16 up until onwards, I will begin to print a new result for that one. So this is typically the forecasted streams. So linear gauge sa 42, 45, 47. So it's increasing, of course. Afterwards, I've actually decided to put that in a CSV file. So it will be sent into this here and will be named as forecasted data with level and trend. So it will be automatically downloaded into my desktop. So it will be Excel file save at something like this. So I can definitely open that, and this is my forecasted data right now. So from that date, from the old data set of of this Bruno Mars, amo man ni ang imong data set kagina, I mean, amo ni ang smooth level mo and smooth trend. So I've only shown here in my um Excel file the smooth trend and the level. So afterwards, this will be the forecast already. So it is increasing 48, 48, o diba? 49 up until in the future that you could somewhat see the trend that it is increasing most likely. So up until 2026, so it is millions or whatsoever. So that's how you will deal with that. So after I've saved the file, I've also checked the mean absolute error, the MSE, the RMSE. So this is here 40 overfitting because the relationship of the three is not somewhat in the same state. So this is not good. This model for the Holtz linear is not suitable for this. So if you want to experience, I mean, check in the future if you want to also deal with this with ARIMA or any linear regression. So you can actually make sure to perform you can check if your data set, if it is stationarity, something like that. So I've actually shown that here then, to check if the data set, if stationarity. So if your data, if it is greater than 0.05, the data is stationarity. So your ADF right now is -3. So it is somewhat stationary. However, if your data set, if it is not stationary, so what you will need to do, since you can definitely normalize everything. So here then, I've actually calculated the difference of your data. Then you could somewhat the first order, second order, whatsoever, to normalize your data set. So afterwards, I've actually tried to imported the since Arima supposedly I wanted to test that. However, I don't have a lot of time because there will be a lot of things that I need to do. So supposedly I wanted to perform the Arima since, but Arima is still not suitable in this case because it will cause a straight line actually. For this one right now, I calculated the first order, then afterwards, uh, after normalizing that, there is this is the Arima that transformed this data into Sarima. So it will be suitable here then. That's the, we're able to check everything from the number of observation, the log likelihood, everything. So that must be, there is a meaning behind that. I will not be going to discuss one by one. Um, Actually, why there is a result, something like this is just as an example on although. So after that one, you will begin to plot that training data with the fitted values. Actually, so after then you will begin to run everything. So this is just a example. This is not a good example yet. However, that you need to get this, if your model, if it is stationary, then afterwards you will begin to complete the process. So you have to do the step-by-step process. So hopefully that it is clear to everybody what you need to do, that it is really important that you will save that into the CSV file, because when I will begin to ask you why that your data here is increasing, so what is the um, what we call this one, data between here, so you could somewhat check that in your data here already, because in your data set, this is the data sets that you do have. So we can check here that from January 1, 18,536, when you will be going to smooth out the data for that January 1, let's try to see if, since we've actually checked that here, that there is a relationship, right, with the level. So we can check the level if that is somewhat connected. So 40,000. So our ano is 18. So they are somewhat connected to each other. For that is 2017. 2017 January 1. Yeah. So that's how you will calculate that one here in the in your implementation. So this is just a breakthrough for that one, though. Make sure that you could somewhat perform this implementation in your data so that you will not your study will not be rejected. Hopefully that you've learned something from that. So thank you.